We want to find the inverse of this function and then determine its domain and range. So our first step in finding an inverse is to interchange the x and y variables. So remember, f of x is just a fancy way of writing y. So if we interchange x and y, then rather than having y equals the cube root of 2x minus 5, we have x is equal to the cube root of 2y minus 5. So first step is just to interchange x and y. And now we're just going to take this equation and solve for y. So in other words, we need to undo the cube root. So we'll undo the cube root by cubing both sides of this equation, resulting in x cubed is equal to 2y minus 5. Then we'll add 5 to both sides. X cubed plus 5 is equal to 2y. And lastly, we'll divide by 2. So we have y is equal to x cubed plus 5 over 2. And that would be perfectly acceptable, or if you'd rather write it as 1/2 x cubed plus 5/2, that would be fine as well. Either way, but you do want to make sure that you use the correct notation in your final answer. So then rather than leaving this as y is equal to, we do want to go ahead and replace it with the inverse of f. We want to use that notation. So the appropriate final answer would be the inverse of f is equal to either x cubed plus 5 all divided by 2, or the 1/2 x cubed plus 5/2. Either form would be fine. So this is going to be my inverse. Then we also wanted to find the domain as well as the range for this inverse function. So domain, we're looking at this inverse function, deciding what are we allowed to have for x. And you'll notice that the inverse function is a cubic. It's a polynomial. Therefore, our domain is all real numbers. There are no restrictions for the values that we can have for x. And likewise, if you just visualize kind of graphically what's happening, if this is a cubic, we know it has that nice S shape, since it's a cubic polynomial, and the range for that shape is also all real numbers. Now, the other way we could check our range is going back to the original. So remember the relationship between a function and its inverse. The range here of the inverse would correspond to the domain of the original function. So you could also go back to the original function and ask yourself, what's the domain for the cube root of 2x minus 5? And we know that since it's a cube root function, there are no restrictions. We can have negatives, positives, as well as 0. So since the domain of the original function is all real numbers, then the range down here, the range for my inverse should be all real numbers as well. Part B, our new function is f of x equals 3x divided by x minus 2. So our first step is to interchange x and y. F of x is just another way of writing y. So if we interchange x and y, then we'll have x is equal to 3y divided by y minus 2. So we've interchanged our x and y, and now we need to solve for y. So this really just becomes an algebra problem. We would want to start by multiplying both sides by y minus 2. That way we can get rid of this division on the right-hand side. So if we distribute here, we end up with y times x minus 2x is equal to 3y. But remember, we're trying to solve for y, and you'll notice that right now in this equation, there's 1, 2, 3 terms altogether in the entire equation. However, there are only 2 terms that contain a y. So we need to get these 2 terms on the same side of the equation. Therefore, we need to subtract yx from both sides so we can get both of these terms that contain a y. We have them on the same side of our equation. So we need to go ahead and subtract the yx. And now you'll notice the right-hand side of your equation here, it is factorable. It has a GCF, and we can factor out a positive y, which is what we're trying to solve for. So if you factor out a positive y, you end up with y times the quantity 3 minus x. And then that works very well because now we can divide the quantity 3 minus x, divide on both sides, so that we can solve for y. So now we have y is equal to negative 2x divided by 3 minus x. So this is the inverse. However, we want to make sure again that we get rid of this y and replace it with the appropriate notation. In other words, what we just found was the inverse of f. So the inverse of function f is equal to negative 2x divided by 3 minus x. Here is our inverse. But we also wanted to find the domain as well as the range for this inverse. So you'll notice that the inverse here is a rational function, and we know that we cannot have 0 here in our denominator. Denominator cannot be equal to 0. Therefore, our domain restriction is that x cannot be equal to 3. There's one value we cannot have. X can be any real number except for 3, because 3 causes division by 0. However, the range for this function might not come to you so easily. We could certainly think about this function's graph and be able to come up with a range, but perhaps there's a faster way. So the faster way is remembering that the range here of the inverse, if we go all the way back to the top, the range of the inverse is going to be the same as the domain of the original function. So if we consider the domain of my original function, which is also rational, again we cannot have 0 in the denominator of a fraction, we see that the domain for this function is that x cannot be equal to positive 2. So if the domain of the original is x cannot equal positive 2, then down here that's going to be the range of my inverse. My range is going to be all values of y such that y cannot equal positive 2. So the range of the inverse is the same as the domain of the original function. It's the x and y values that are being interchanged. So here's our inverse function as well as its domain and range.